So far, we have seen the various techniques using which we can solve the find peak element problem, right? Now, let's quickly write the Python-based implementation for the same thing. So, inside the searching folder, whatever we have, created for organizing all the searching related implementation, since it is our first searching related problem that we are trying to solve, I would want to create another folder called practice inside the searching folder, where we will keep all the problems that we will be implementing as part of the searching practice. So here inside this file, let me just create another file called findPeakElement.py. Okay, so in this file, let's write the solution for finding the peak element in a sorted array according to the problem statement that we have got. Here, let me just define a class called find peak element. Okay, inside here, let's just define one function called find peak element using binary search. Okay, so whatever the other approaches that I have explained, all the solutions will be available on the codingpal.org. I'll put the relevant problem links in the description box so that you can go ahead and check those solutions as well. But our ultimate aim is to solve this problem using the effective approach, right? So I'm going to explain the binary search based solution here in this video right now. If at all, if you want the other solutions, you can go ahead and check out the codingpal.org using the link down in the description. Okay, so anyway, as part of the problem, we will be given an array of values, right? So the array of values I'm accepting in a variable ARR. Now what we need to do, we can solve this problem effectively using a binary searching, right? So in binary searching, we will have a starting index. So I'm going to define one variable start and I'm going to initialize it with 0. Along with that, I will also define another variable. This variable will basically hold the last index that we have in the array. So it will be length of the array minus 1. Okay, along with that, going forward, when we run the loop, we will need to calculate the middle index, right? So for that, what I will do is I will create one variable called middle and I'm going to initialize it with minus 1. Now all we need to do is we need to run a loop as long as this start is less than end. Inside this loop, what we will do, we will calculate the middle. So middle will be start plus end divided by 2. Okay, so here, since we are going to use Python 3, right? Python 3 division will basically give us the floating point number. As a result, since we have a valid integers as indexes in the array, let me just import the math library and just floor this result. So math.floor. Okay, so this will give us a whole number for using the indexes. Now all we do is, if the value at the middle index is less than the value at the middle plus 1th index, then what we need to do, see, we've calculated the middle index and whatever the value we have at this middle index is less than the middle plus 1th index. That means the greater value is there on the right side, right? So to go ahead and search on the right side, what we will do, whatever the start index that we have, we will simply update it with middle plus 1. If this is not the case, that means whatever the middle index that we have, its value is greater than the value we have on the right, I mean middle plus 1. So the peak element could be there on the left side. So for that, what I will do is end will be equal to middle. One thing that you need to observe here is I'm not updating it with middle minus 1, because whatever the middle index that we have right now could be holding the peak element index. As a result, it should be there in the search range. That's the reason why here I'm not going to update the end with middle minus 1. Okay, now once this loop is completed, in the end, whatever the start index that we have will be holding the index for the peak element inside the array. So here ultimately we will simply return start as the return value. So very simple binary searching usage. All we need to do is we will calculate the middle. If at all the value we have at the middle is less than the value we have at the middle plus 1th index, we will simply move on to search in that range. As a result, we have simply updated the start with middle plus 1. Otherwise, the end will be middle, so that we will only search for the peak element in the left part of the array ranging from start to end. Okay, in the end, once this loop completes executing, whatever the start variable we have will be holding the peak index in the array, and we will need to return that. Okay, now let's just try to test it out. So here I will be running the problem on only one test case. If at all, if you want to run it against more test cases, you can go ahead to codingpal.org and you can find out all the test cases, and you can try to run it and evaluate according to the steps that we have discussed in the algorithmic discussion. Now anyway, let me just define an array, and in this array, let's just say the values that I want is 1, 2, 3, 5 and 0, 1, 2, 3. Okay. Now along with this, I want to call the find peak element using binary search, right? So first it is inside the class find peak element. So let me just create the object of that. Okay, and after that find peak element using binary search, and let's just pass the array, and let me just store the peak elements index, right? So let me just create a variable peak index, and after that let's just try to print peak index. Okay, so now let's just try to run it. To run it, since we have installed the runner code runner plugin, we can simply choose run code option, and if you see, the index that we have got is 3. If you look at the array of values that we have passed here, and the index 3, 0, 1, 2, 3. Index 3 has 5, which is the largest value, which is nothing but the peak value. According to the problem statement that we have got, we can either return the index of 5 or we can return the index of 3 as well. That is completely up to you. And one more test case I want to test it out is, let's just say I want to test it out on the array which has only one value. So in that case, what we need to do here, it has only one value, right? So ultimately it itself is the peak element. So if I run the code right now, I should get 0, which I have got. Okay, similarly, let's just say the array that I'm passing is empty. In that case, ideally what we should do, we should basically return -1, but we are returning 0. So to handle that case also, so the way I have implemented so far this solution is assuming that there will not be any empty array being passed as an argument. But if your interviewer says that you will be given a array where the size could be empty, in that case what you need to do is you just need to modify this implementation. First, let's just calculate the length, and after that, if at all the length is equal to 0, in that case simply return -1. Otherwise, use this logic. So for that, let's just align it. Okay, now here, instead of using length of array, once again let's just use the length variable. Now if I run this code right now, I should get -1. Okay, which I have got. So we have successfully validated important scenarios of finding the peak element as well. Like I mentioned, if at all, if you want to validate few other scenarios, go to codingpal.org and find out the different scenarios and evaluate this solution against those test cases as well. That's it for this find peak element. I'll see you in the next problem.